This last week I've been really trying to work towards command line compatibility of my compiler to the Microsoft compiler. And the way I've been going about this is essentially to download random projects off the internet that are relatively easy to compile with just the Microsoft compiler and try to compile them with my compiler. The project I want to look at today is this immediate UI library thing that's like a single header file. Single header file libraries are usually easy to compile, so they make good examples. What's good about it for me is that it has demos, and we are going to look at the d3d11 demo. They are just compiled with a simple invocation of the Microsoft compiler. What I've already done and what's been my workflow is simply to replace this invocation of CL with HLC and make whatever comes up work. So let's see where this is right now. So here is the version of this code that I've checked out in this build script. You can see I've replaced the CL with an application of my compiler, HLC. Other than that, I didn't change anything. And now if I run build, it reports an error at ID_ID3D11 texture 2D. And so what's going on here is that we have this external declaration, which is never defined inside of the code, because this declaration is supposed to come from this library dxguid.lib. But my compiler at this point does not support static linking. Essentially, these libraries, these GUID libraries, uuid.lib and dxguid.lib, are statically linked to some extent. They don't contain import symbols, but rather they actually contain the data that's in there. There are two issues that I see here. First of all, it claims that these libraries do not export any symbols, which is sort of wrong. They just don't export any symbols that we can currently pass. And then here the error is also really bad because it tells me, well, we couldn't find this declaration. But if we looked a little harder, we could find the declaration and only complain about it not being an export declaration and then say we are not supporting static linking at this point. But then the second step is actually to support it, because these are sort of special libraries, I think. And so these only export data symbols that have no relocations. If I find that, I think I can actually implement linking to that. But first of all, I want to make it so that this warning doesn't happen, because these are actually exporting symbols, just not export symbols. And then second, that here there is a better error message. So let's start on that. Here we can sort of see the code that is responsible for it not working, not finding any symbols. This is the warning that we are seeing. Library does not contain any symbols. And the reason it is not printing any symbols or not finding any symbols is because here I check that the symbol in question starts with a --imp dash. And this is how import symbols are usually defined by the Microsoft compiler. But these import symbols are in there twice actually, once prefixed with this --imp symbol and another time without it. So I'm pretty sure I can simply get rid of this and then get rid of the import symbol base. That will make us find all the symbols, and linking should still work. can see I removed just these few lines of code, had this import symbol base, I removed that. It still works, all tests of my compiler still ran successfully. Going to call that working. And at least the warnings are gone. So the next step is to figure out where this error message is printed and then provide a better one in the case where we actually can find the symbol, but it's not an export symbol. Okay, here is where the error is printed, and essentially this is a loop that computes the reachability information for the program. So essentially going over all like referenced nodes, all entry points, and then checking if it's reachable. And I have some graph that tells me which declarations are actually reachable from main, so that I don't emit declarations that are unreachable. And this is actually necessary for like inline functions that reference non-defined declarations and stuff like that. It gets a little bit confusing, a little bit hard, but all this does is essentially visit all the declarations in a depth-first way from every entry point of the program. And here, when I find one of these declarations, I mark it as reachable. And when it is reachable and we're not producing an object file, and we have a declaration that is never defined and is extern, then we say that this was an external declaration that was referenced but never defined. So I guess here we now want to look up the symbol. The thing that gets a little bit complicated here is that so far the whole system thinks it's returning a DLL import node, which means an external declaration. But now this is sort of supposed to look it up and tell me whether or not it is defined, whether it is an import node or it is a data declaration or like a static declaration. And we also want the same thing for functions, more or less, because they are currently, it would also just fail saying it doesn't exist if it is a statically defined function. So this AR lookup symbol actually has to return something different. So I'm going to do that for now. So essentially how these library files work, so the .lib files, is that they have like a table of all of the identifiers or symbols that are defined by the library, and then each of these symbols is mapped to an offset in the file. And at that offset, there's either one of these AR import headers for import symbols or an object file, starting with a image file header. And I think what I'm going to do is return essentially that from the AR lookup symbol. That makes the most sense to me. Then whoever calls it has to figure out what he wants to do with either the image file header or the AR import header. Okay, now instead of returning these DLL import nodes, I have the code that handles DLL import nodes right here, saved in the Scratch buffer. And we now return the more raw data of just the pointer to the file plus the size of the file. This is sort of annoying because I want to give out which library in which library it was contained, so this function doesn't really work unless I return even more stuff. Also, if this one is the first one that didn't fail and it returns an object file, this would then complain. But maybe I want to look up further and find one that isn't in an object file, so isn't an object file, so isn't a static symbol, and find the dynamic one and only one. I think that's what I want to do. And so I'm going to do it manually here at first. And then I think because I want the same code like 4 times, I'm going to make that a function after I've found the correct code to put here. We iterate all of the libraries, we look up the function identifier, and then when we find an object file, I feel like we are supposed to remember that we found an object file, found a symbol in an object file. If we ever find it in a DLL, then we are done and we can do this grab. And if it only ever fails, and then in the end we have to report this error right here. So I think it is done for the most obvious case where you have a function that is declared as DLL import. For that, I now do exactly what I thought I would. I iterate all of the libraries. And if it's an import header, I say I found it. Otherwise, I remember the object file. If we couldn't find it, I either say, okay, if it was declared statically somewhere, I say that it's declared DLL import but defined in a library. And otherwise, we go into the case that we had before, where the function is not contained in any of the imported DLLs. If we found the AR import header, then I report a warning. If it was also declared in some object file, like this object file path was it. And otherwise, I do what I did before, which is, and I have to do a very similar thing right here. Namely, if the function was not declared DLL import, it might still be a DLL import like implicitly, sort of. Namely, what link.exe does in that case produces one of these jumps and also imports the node. Essentially here we have to do the same thing, but probably with different error messages. But what I'm going to do first is extract this whole function. So actually what comes to mind here is that it should work a little bit differently in this case. Because here, in this case, if we find it in an object file, I want to see if the thing is easily linkable. And also I want to complain about it. But maybe I still want this sort of function. It just has a flag like allow static linking. And then it returns something that's either a DLL import node, like in this case, or not a DLL import node, but like the actual location of the thing if it was easily linkable. And like a return value again. Okay, now I check if it is not a DLL import right here, then I allow COF file headers. But for now, if there is a COF file header, I just say static linking isn't supported and return out. Otherwise, I do what I did before. So if it's an import header, like at this point, we know it's either a declaration that is not DLL import, but we are looking up an import header, or it's a declaration that is DLL import, and yeah. But I have to rework all of this part to make sure it handles the case where this is not a DLL import. So let's try that. Okay, if we cannot find the symbol, then either we're in the DLL import case, in which case we say the function is not contained in any of the imported DLLs, or we are in the non-DLL import case, in which case we are saying the function was declared and referenced but never defined. Here the function was referenced. Then at this point we know that we have either found it in that we either have an import header or we have an object file library name. Then if we have an object file, which implies that we are not DLL import, then we are in the static linking case, which is incomplete for now. Otherwise, here we know that we are not in the static linking case. This thing should now pretty much only be this thing. We also have to deal with the DLL export case, which is a little bit weird, but so the DLL export case, the function cannot be marked DLL export and DLL import at the same time. And we are not supposed to look it up in the DLL import node in the libraries if it is marked DLL export. That makes no sense. Hence, I feel like I can do this one first. So if it's marked DLL export, then sure, I'll say it must be defined or something. And otherwise, I execute this function here. Which makes me want to inline this function right here, but we'll see after we've got it to work, I think. And then this whole thing is still the function versus declaration thing going on. So let's fix up that. Declarations currently do not have a DLL import node. Okay. Whatever, I don't want to deal with it. Okay, it compiles, which means hopefully it does the same thing as before. So we haven't really done anything so far. We haven't improved anything except error messages for stuff that we are currently not testing. But I should now be able to run all the tests and see if anything breaks. Yes, everything breaks. Compiling the test runner broke because object file library named data. So we do not have an AR import header. I don't think we set this lookup result anywhere. And here's a return missing. Okay, now it complains that nothing is imported anywhere. I think because everything is failing because we have failed to initialize this here symbol. So in AR lookup symbol, we think start out, even though it's implied by the value, to set up the lookup result to failed. When we have an import header, we return that we have an import header. What does it look up? Result is AR lookup symbol lookup and import header. Otherwise, here we are in the object file case. Is DLL import. What did I miss? That is just not true. Yeah. Console, please tell me. This exit process was defined in this library. That is an error referenced function declared DLL import. So we are here somehow. We don't have an AR import header. This could be one of those things where I missed something which would be annoying. So maybe these aren't all import symbols, or something is going wrong with the logic. So let's first of all set a breakpoint. And observe this. So, sure. Tests runner. Here, what do we have? AR import header. Nothing. Conf file header. Nothing. Okay. What are we looking up? Get command line A. Okay, I forgot to return these values here as well. The file size and the conf file header in this case. Not that it matters for the error message we're getting. My hope here is that I just screwed up these signatures and they're not both -1, but like one of them is 0. That could be a true as well for an import header. Okay, the first one is 0, the second one is OXFFFF. Whew, that is sort of saved, I think. I was kind of scared that there are actually statically linked symbols in these files. And with that, the test runner compiles again. Ignore all of these warnings, they have nothing to do with what we just did. I mean, they are from the code, but that happened before as well. It's overly aggressive right now for some reason. Like, it's not supposed to report errors in system include files, but it is. Anyway, not important. It is working. Now we can run the test suite. For whatever reason, the test suite sometimes hangs, and I really have to figure that out. It is really annoying, and it happens every time on this computer. And it has to time out something, and it takes 30 seconds. And it happened again. Anyway, I'm gonna assume that works now. Nothing should have changed for the file that we actually want to compile. Right, same thing. But now we should be able to just simply call this function as well for the declaration case. So now if the declaration does not have an unsigned expression, which means it's not defined, like it doesn't have an initializer, and it is extern or DLL import, then we have to look it up. And so we call the lookup declaration in libraries. And then this error right here should be equivalent to some error like this. %s was declared and referenced but never defined. This is sort of what this is saying. And now I'll run the test suite again. There was a fail there. But that one just failed because now the error message is different. So I'm gonna deal with that later. Which means, no, I assume it works, whatever. And we can test if it works here. What does it say? But static linking is currently not supported. So that's the first part done after only 1.5 hours, which I thought would be easy. Okay. Now the slightly harder part, maybe, is to actually figure out if we can extract the data in it. Yeah, as we can see, in this file, there's like one rdata section per symbol. So we always have like a static symbol in a section that only contains a single external symbol. All of these are declared pick any, so the decal spec select any keyword, and are only here to fill out these GUID definitions. So all of these sections should contain exactly one symbol, and this one symbol should be the GUID in question. So I feel like I could just read that. And here it's probably good to steal some code from my linker project. But it seems like that one's outdated, so I'm gonna have to pull it first. Oh, I was in the wrong folder. Okay, I got the symbol name out. It's always a little bit more cumbersome than it needs to be, because either it's inline, if it's smaller or equal to 8 characters, or it is an offset, U32 offset, into a string table. And there's always a special case where if the short name is exactly 8 characters, it is not zero terminated. But okay, I got it out, and now we can check if it is the name of our declaration. So I'm pretty sure these section numbers are one-based. Like 90%. I guess I could check here. Yes, they are one-based. Okay, so if we found the symbol, we get the associated section to it, and if the section has no relocation and the size of the section matches the size of our declaration, then it's a simple section that just is some data. So we set the memory location of our data of our declaration to point to exactly that, which means when we emit the executable, we should copy it from that location. Here I could check for that it's the same kind of thing. So let's do that. But this should maybe work. And then here return 0 and here we return 1. Let's fix up all of the errors. All right, let's see if we get through this or if we just completely fail. We just completely fail. Let's see if we even get into this function. So far so good, we are doing stuff. Okay, it seems to me that probably these are off. I added 4 because I thought there was a size at the start of the... Like this, supposed to probably be this. Like have an IID underscore in front of it, but I added 4 at some point because I thought that was correct, but maybe not. Like right here is a +4. So let's just remove that and see if that works. So let's just ship it. Oh, and that, as you can see, produced an executable. Now, does it blend? It does not blend. Okay. So why not? Probably because somewhere I check whether or not it has an assign expression. So for now, let's take this context empty statement maybe. Context undeclared identifier. Sure. Hacking it up even more, but I really want to be done. It was not on context. We can go back to this one, which makes me slightly more happy. Then I have to check one thing really quick. It'll just show up if it's wrong. Cert fired and evaluate static initializer. It is wrong. That's what I was thinking of. Essentially, we are trying to evaluate this now. For static variables, sure, but here. Could flag it. Could simply do this right here. Seems like the best way. And with that, the demo works. Whew. Very nice. So that was slightly harder than I thought it would be, especially the first part. There the factoring was kind of hard. But then passing the object file worked really nicely in the end. And now we have linking to very simple object files, which means to very simple, essentially object files, but inside of libraries, like these data-only static libraries. And I think this is all that is required to link to essentially all libraries in the Windows SDKs. So I only have to clean that up, make it nice and pretty, and then dynamic linking is done, pretty much. Anyway, I hope you enjoyed this. It was a little bit gruesome at times, but we did get through it. And maybe see you next time.